We're gonna see what we have so far finished with performance tuning up to JVM. We'll see these three things in a short session. Today's session is kind of short, so we have to deal only with what is left out. Out of these three, this is the most important, WebLogic. So, alright, and before we go into WebLogic Server, just the JVM itself, just to summarize what needs to be tuned. We're looking at the third parameter to tune. Third parameter to tune in JVM is the type of GC. The second parameter was the compartment sizes. The compartment size is basically what is new generation size, what is old generation size, what is perm generation size, those three things. And the first parameter that we tune usually in JVM is your XMS and XMX values. So those three things to tune in JVM, especially when there are issues like stuck threads, when you have issues like out of memory. And we have also seen how to take a thread dump, how to take a heap dump, how do you enable garbage collection logs, and we did look at GC viewer to understand how the garbage collection is happening, and we looked at the thread dump in Samurai to understand how the threads are behaving, all that stuff. Alright, then the next thing is the work managers. Now the WebLogic server parameter is what is next in that stack. So this is, let's say, 20th slide number. Third one. We are here at WebLogic 20th. So WebLogic server tuning. So let's jump into WebLogic server tuning. Now this is what you're going to tune in WebLogic server. The first thing is, instead of execute queues, we will see what is an execute queue. Instead of execute queues, we can use work managers. We can tune the percentage of socket readers. Enable native IO is already done, and you can tune stuck thread max intervals. These four things can be tuned at WebLogic server level. Now out of all these things, this is the most important thing. So what is execute queue and what is work manager? If you look at this thing, this is an execute queue. Execute queue is a queue that takes up the requests that are incoming to a JVM. Let's say the blue box you are looking behind is a JVM encode manage server. When the requests land onto that encode manage server, they all will be waiting in a queue. The name of that queue is called execute queue. Now the execute queue is associated with what is called a thread pool. A thread pool will simply have the list of threads. So there might be T1, T2, T3, T4, like that. These are called execute threads. So you have execute queue, execute threads here. The threads, the number of threads in the thread pool, in 8 it used to be fixed around 25 or 25, because we are saying it's fixed. So, but in 9.2 onwards, the thread pool is called a self-tuning thread pool, which means the number of threads is not fixed. It starts with 3 threads. The thread pool initially has 3, but if the number of requests go up, the number of threads also in the pool will go up to certain extent. But it does not mean that it can go up to infinite. Obviously, thread pool is all part of the JVM. So you have only XMX value allocated. So the WebLogic will try to balance the overall JVM heap size versus how much thread pool is consuming. Alright, so the request will fall here, and the request, now if you see that, uh, let me open the zoom it. Now the request landed here. When the request land here, they are waiting in the queue. So let's say the requests are like this. Request 1, request 2, request 3, request 4, like this. Alright, or else otherwise reverse. Request 5 had just arrived, request 4 was already there, request 3 was already there, request 2 was already there, request 1 was already there. So let's say this is the FIFO queue, regular queue. So the request 1 has to be served first. Now the same way here on the right side you have threads. T1 is there, T2 is there, T3 is there, T4 is there. Let's say number of threads are there. Now each thread gets allocated to one request. That's a normal behavior. WebLogic allocates one thread for each request, the default behavior. So when Executeq is there, requests come in, each request gets a thread. Now look at the scenario here. Now let's say request 5 is a more important request than the remaining requests, which means we would want R5 to be taken up early, or we want R5 to be given high priority. Means it should be able to jump the queue. That's point number 1. The second point is, once it reaches this end point, means once it gets allocated the thread R5, we don't want just one, but we want probably more than one. The reason why we want more than one would be, let's say we want to finish quickly. For example, a fund transfer like transaction. It wants a priority and it also wants to be finished quickly within time. So those are the two things. One is the request prioritization. Alright, request prioritization. That's not possible in Executeq. Then the custom thread allocation. This is also not possible. Request prioritization means the ability to jump the queue. Whereas custom thread allocation is once it reaches its place, alright, to the beginning of the queue, R5 should not just be the thread allocated to R5, but we want more. So these two things basically led to the introduction of what is called a work manager. So a work manager is what solves these two problems. A work manager. So the work manager here can solve these two problems. One is request prioritization. It can allow custom thread allocation. Now let's see how it does it. Now this was introduced again in 9.2. Alright, work managers. Earlier they were only Executeqs. Now it's not mandatory that a WebLogic server should have a work manager. It's okay not to have a work manager, in which case you are simply using the default Executeq. But when you tune the performance, basically that's when you create work manager. Right? So why we are using work manager is basically those two things. First one is request prioritization. Second one is custom thread allocation. These are all other ways of saying the same thing. We'll probably come back to this screen. Let me just, okay. Now when you compare Work Manager with Executeq, what we can do is, in a typical application, a regular application, so you have a server, alright, then there is a Work Manager like this, WM1, let's say. There is a thread pool associated with it. Alright. A thread pool associated with it has threads. Like this. Right. Now the request will flow in here. Now how do we usually send requests to Work Manager is, in the var file that the developer creates, there is a deployment descriptor called weblogic.xml. In the weblogic.xml, we'll put a tag, Work Manager, let's say WM1. Close the tag, XML tag. So here this tells us, alright, this tells us that any request coming out of this var file, weblogic.xml is for a var file, that we know. The other file is web.xml. So a var file consists of a weblogic.xml. So all the requests coming for the code in this var file will be redirected to this Work Manager. That will be done by the managed server itself. Let's say our managed server name is encode mng1. So what we are essentially trying to do here is, when a request comes in code mng1, depending on the request URL or what application the request is for, the mng1 will allocate it to the corresponding Work Manager. Now let's say this Work Manager is associated with application 1 or var file 1. Let's say var file 1 is deployed as application 1. So any request that's coming for this app 1 will be handled by the Work Manager. Now the reason why we have Work Manager is for request prioritization. That is already done, which means when other requests come in, they will wait in a regular queue. The execute queue will be still there, guys. It's not that you are replacing the execute queue. The Work Manager is specifically for this application. Any request that is not coming for this application will go into the regular execute queue. So the execute queue, you basically prioritize the request R5 by sending it to another queue. It's like, let's say at airport you have, a regular economy class versus business class and first class. The first class guys are, you are a diner card holder. You go in a different line. You directly walk in. So that's how you get priority. So here these requests R5 did not go into the regular queue. Instead it went into a special queue. Now the special queue request prioritization. Now once it goes into the special queue, the second thing that we said Work Manager will help us is with the number of threads. A regular execute queue request will get one thread per request. If you're getting one thread per request, you should finish it. But if somebody comes to a Work Manager, the Work Manager can decide how many threads it can allocate to the request. Means the Work Manager can be designed in such a way that it can dynamically calculate the number of threads required and allocate the threads. So what the Work Manager does here is, it can say every request that's coming here, let's say R5 is here. R5, work manager 1 can promise R5 will be finished within 5 seconds. Now how does this give such a promise? Now normally what work manager does is, work manager knows the request because all the requests coming to this work manager are from the same application. So work manager probably, it basically knows how much time it takes for R5 to finish from its previous history. So earlier when it worked out on other requests, it knows how much such a request takes. Now it uses the historical data and tries to calculate the amount of time R5 takes for one thread. So let's say from the historical data, work manager knows that with one thread, it's going to take 10 minutes. Alright, one thread, it takes 10 minutes. Now if it takes 10 minutes with one thread, let's say we are trying to give 5 minutes response time. Let's put it in seconds. Let's say one thread, 10 seconds. Then we realize we want to give 5 seconds response time. So how many threads I will need? 2 threads, isn't it? I hope you did that calculation. So 2 threads. Now 2 threads will be allocated. If I need 1 second response time, probably I'll allocate 10 threads. That's not good, but still that's a calculation. So work manager can dynamically decide how many threads are required to calculate a request within the promised time, which means work manager can be implemented to set up SLAs. Now this type of work manager where it worries about the response time is called request class response time work manager. Just like that means any request that's coming into WM1 will be finished within the given time. That's what it's saying. And to finish it in the given time, it's going to implement or it's going to allocate the number of dynamic requests as required. Now, just like a response time work manager, there are a couple of other work managers. There is a fair share work manager. Alright, then there is a context work manager. It's gone. Okay, let's retry it. It's gone, the images. This is work manager. Alright, then you got a thread pool. Then you got to Executeq. Alright, request gets prioritized here. There are threads here. Like this. Now, the first type of work manager that we talked about is response time work manager. The second type I was talking is a fair share. The third type I was talking is context. Now the logic of implementing a response time means the work manager has to calculate how many threads it requires and how many threads it allocates. This is all a piece of code, Java code. Now that Java code is written in obviously in Java, so it's bundled into a class. So the class that implements this type of work manager, or the work manager's logic is put into what is called a request class. So here you call a first type of work manager as response time request class implementing work manager. They're all called request classes because they are the logics that work manager is implementing. Fair share request class, then a context request class. So what we are saying is a work manager either is implementing response time, means it is trying to give within a specified response time, or you can create another work manager. Alright, it can work as a fair share one. Fair share one means, let's say there is an application app 2. There is also another application, let's say app 1 on this one. Now assume app 2 receives very less number of requests, but app 1 receives large number of requests. In that scenario, what happens is app 2 requests will have to wait in the queue for a longer time because app 1 requests are more. Look at this thing. Let's say this is the queue model. So I have a queue. Request for application 2 just now arrived. Application 1 was already there. Application request for application 1 was there. Application 1 was there. Application 1, like this. Let's say a queue is filled with too many application 1 requests, then an application 2 request arrived. So I'm looking at, I put the queue in reverse order. So here A1 is at the beginning of the queue, request for application 1, and request for application 2 just now arrived. Now this A2 means this request for application 2 has to wait till everybody else clears off. That's what would happen in a general execute queue. Now to avoid that, so this basically application 2 is suffering performance because of load on application 1. So what we do is we assign a fair share work manager to application 2. So what we'll say is all the application 2 requests will come to work manager 2, let's say. So here the work manager 2, so application 2 weblogic.xml file has a work manager 2 defined in it. Now when work manager 2 is defined in here, the request will come here. Now this work manager allocates a fair share of threads to app 2. This is more like a reservation system. So what happens in a reservation system is a certain part of the number of seats are reserved. Let's say for example women's reservation in India 33%. So 33% of seats are reserved for women whenever they come. That's the point, whatever is that rank or what. Now here when the request comes in here, this work manager can be said to be allocated, let's say 10%, 20%, 30% of the thread pool to this work manager. So I'll say 10% or 20% allocated to app 2, to whatever work manager this was, to whatever application this work manager was allocated, that application will get 20. The remaining applications in that JVM will get the 80%. The same way, if you have another application app 3, you can define another work manager for that one, give certain percentage to that one also. Everything remaining will go to the execute queue. So that way what you're doing is you're specifying certain percentage of thread pool. By the way, the thread pool is a single thread pool, guys, for all these work managers. Whatever number of work managers you have, there is always a thread, execute thread also, default one for any unassigned request. So thread pool but is same. So what we are doing here is a request coming to work manager 2 have a reservation already. 20% of the seats are already reserved. Then there is a third type of work manager called context work manager. This is basically recommendation system. Recommendation system means if the request is coming from a user, or it's coming from a specific group, or it's coming from a specific keyword in it, it will be given priority. Means you will define a separate work manager. Alright, WM3. In that weblogic.xml, I will define the users, groups, and keywords, and if it is coming from that users, group, and keyword for that application, you will send it to the work manager 3. The work manager 3 tries to prioritize that request. So that way you got 3 types of work managers, you can say. And when you are defining a work manager, you can define only one of these types. So basically these are the types of work managers: either response time request class implementing work manager, fair share request class implementing work manager, context request class implementing work manager. Now when you are doing this one, you might come across certain other parameters or certain other constraints. For example, let's say a thread pool has 10 threads. I said T4, T5, like this, up to you have, let's say, T10. Right? Now when you have a thread pool, let's say there is a response time request class you are implementing. You realize with one thread it's taking 10 seconds. So what you did was, you're going to give 1 second response time. That's what you said. Which means you're exhausting 10 threads per request. Let's say you went ahead by mistake or something, you said 0.5 seconds. Which means you have to give 20 threads per request, which you don't have at this point. If you don't have, WebLogic will try to increase the number of threads dynamically. For multiple requests, it's going to do the same thing. Eventually, it will run into a problem. So, because of the configuration issues, you may run into problems that are unintentional. So, what you do is, you will restrict the number of threads a work manager can allocate, the max number of threads. Means the work manager obviously has the liberty to allocate the number of threads, but it cannot allocate, undiscriminating. Means you should understand, or it should do it with proper limits. So what we are saying is, even though here your calculation comes to be 20 threads, don't allocate 20 threads, allocate only n number of threads. That's the max you can do. So there is a parameter called max thread constraint. The max thread constraint, let's say you set it up to be 5 or 10. Now if you set a max thread constraint for this work manager to be 5, even though this work manager calculates the number of threads required are 20, it will still allocate 5 only at max to your request. That way you are giving a freedom to the work manager to allocate the number of threads. At the same time, you're also restricting with a max limit. Alright? That way you won't run into problems like thread exhaust, unnecessary thread creation in the pool. The next similar property of a work manager is a min thread constraint. A min thread constraint basically tells the number of minimum threads that should be allocated to a request. By default, one thread gets allocated minimum. Let's say every request that's coming into this work manager requires 3 threads minimum. We know that already. If we already know it, then there is no point in giving one thread first and changing it later. So what we do is, you start with the minimum, let's say 3, then you adjust it accordingly. These three threads will also help in avoiding any deadlocks that the work manager might encounter, because there are 2 or 3 threads together. So the 3 threads together will be able to finish the activity. If it is only one thread, probably it may get into a deadlock. The next and the last parameter of a work manager property is capacity constraint. A capacity constraint basically tells how much is the length of the queue of this work manager. The work manager also has a queue, right? So at some point of time, this should say, that's it, I cannot handle any more else. So what we will do is, once it reaches a certain distance, certain length, you restrict it. Let's say a capacity constraint, if you say 50 requests can be queued into the queue. Anything beyond 50, so this is 50. The 51st request here will be rejected. It basically says connection refused error. So these 3 are the other parameters that any work manager would probably have. This is the type of a work manager. These are the properties of a work manager. So I can save it. Let's just open it. Alright, so when you create as an administrator, you will be asked to create these work managers because they're already defined in the weblogic.xml. So when you your job is to basically create the work managers, assign one of these types and assign these properties. Now out of these properties, obviously, no, that's not possible. You can't send it to the queue of the work manager. Yeah, that can be done, yes. Why not? It can be done, yes. The work manager cannot take up the request. It will go to the default execute queue. It is not prioritized anymore. It has to go back to that regular model. Now the creation of this work manager, so if you say, let's go to our domain admin console. Let's go to our domain, start the domain. Oracle middleware user projects, domains, and call YAML. Go to bin start admin.sh. It's in verbose mode. Let's take out that verbose thing. It's going to fill up the log file. So I'm going to disable that debug mode. Okay, admin is up. Log into the console. What happened? Port wrong. Okay. What is our port? 20,000. 20,001. Okay, SSL was 20,000. Excellent. So let's log in. WLS admin 123. Alright. Now let's create a work manager. So in the environment, you have work managers. So create a new work manager. Now when you create a new work manager, you see these things. You create an empty work manager first. Then you can create any of the 3 properties that you want to allocate it to work manager. Then any of the other constraints that you want to put. So this is a property. These are the constraints. So let's create a work manager first, an empty one. So let's call it anything you want. Let's say WM1. Now the name of the work manager will be given to you from the developer, because that's already put into the weblogic.xml. So create the same work manager. Let's say assign it to all the targets wherever you want. Right, because that's where the request will be landing. Assign it. So work manager is defined. So once it is defined, go into activate the changes. Go into the work manager. Then you can define the request classes: min thread constraint, max thread constraint, capacity constraint. But before you select or define these properties, they have to be listed. They will come here in the drop downs. Alright, so let's go back and create these properties. Work managers, new property, response time request class. Next, let's say that this is response time request class 1. Let's say the goal is 5 milliseconds. These are all milliseconds. You want to finish every request in 5 milliseconds. Want next, target it, finish it. Same way you can create a fair share request class, assign it later to the work manager. So fair share request class, how much is the share? Alright, so if you say, let's say 20%, means 20% of the thread pool will be allocated to this work manager. So this work manager will be able to serve the request based on the reservation that it's allocated. Want to next, finish. The same way you can define a context request class. The context request class, there is nothing to define here. What's the context? The context will be defined in the application weblogic.xml itself. So these are the properties. Now let's create a constraint. Max thread constraint. The maximum number of threads to allocate for requests. Alright, so here you can say, let's say 5. So 5 threads will be allocated for every request. That you can say, or else you can say, whatever is the connection pool size of my data source DS1, allocate. The idea here is, if all the threads you have allocated are requesting connection objects, let's say a connection pool has size of 5, but the number of threads you have allocated are 10, and assume all the 10 are asking for a database connection. But there are not enough database connections because the pool size is only 5, which means you're wasting 5 threads. So you don't want to unintentionally allocate more threads that are all requesting the connection object, but the connection objects are not available. In that case, what you do is, whatever is my data source connection pool size, that's the max thread constraint. Means only those many number of maximum threads can be allocated. That's one way of saying it, or else you can give a fixed number. Either way, it depends on the application. If your application requests are completely database dependent, then you would rather go with the data source name. If they are not dependent, means if there are other regular queries versus database related queries, you will optimize this number. Optimizing the number, everything gets done when you are doing a load testing, guys. All these numbers, they have to be optimized only after load testing. So you have created a max thread constraint. The same way you can create a min thread constraint. There's a minimum number of threads allocated for resolving deadlocks is 3. So go on, finish it. The same way you can create the capacity constraint. How many requests it's going to take before it rejects a fresh request. Let's say 50 is the work manager. You want to define the number of requests it will take in the queue. On the queue, guys, when one request 49 it comes, it start taking one more. So at max 50 is the queue length. Now you have defined all the properties. Go into work manager. Now you will be able to allocate. So you have created these 3 properties. You can assign one of these 3 to this work manager WM1. Let's have a save response time. Min thread constraint we have created, max thread constraint we have created. Then you have a property called ignore stuck thread. Stuck thread, we know that stuck thread is anything that's running for more than 600 seconds. Now the question is, if you ask the work manager to ignore the stuck thread, alright, it goes on, it ignores the stuck thread, alright, and then it moves on. Sometimes what happens is, if there are stuck threads, your WebLogic will usually shut down the work manager, because the threads are stuck, the work manager is not able to function. So the requests that are coming into the work manager cannot be completed anymore. So what the WebLogic does is, once it sees that a thread is working for more than 600 seconds, the threads will be stuck, and the application server, WebLogic server itself, will try to shut down that application, shut down that work manager, and probably sometimes take this manage server also into admin mode. Now if we don't want that, then we will ask the work manager to simply say, please ignore any stuck threads. If something is running for more than 600 seconds, let it run. Now when you will assume this kind of thing is, or when you will assign, or when you will basically select this one is, when you know that your requests are genuinely taking more than 600 seconds. Let's say the requests are normally taking more than 600 seconds. So even though WebLogic says they are stuck, they're going to finish in 800 seconds. So you don't want WebLogic to turn your application into admin mode, or turn your work manager, or shut down your work manager. So that time you will say, please ignore the stuck threads, continue with the work. They are going to be released when it is 800 seconds. So stuck threads, when you have a problem, and if they are not stuck but genuinely your application is taking more number of seconds, then you may choose to ignore the stuck threads. You can tell WebLogic to ignore the stuck threads by using a work manager. So once you have done it, save it. That's it. That's your work manager's creation. Yes, you should have a monitoring tool or a Unix script that basically goes through the log file from frequent at time to time, and if there is any stuck thread, it will send out an alert to you. You can have either a tool or a script in a cron, but that somebody has to be monitoring the log file because whenever there is a stuck thread, your log file will show those stuck threads. All that you have to do is simply capture those errors, either using a tool or a Unix script. Have it send out to your popular tool is Introscope. The most popular tool is Introscope. The upcoming tool is Enterprise Manager 12c Grid Control. OEM, Oracle Enterprise Manager Grid Cloud Control, it's called now. So 12c Grid Control is gone. It's called Cloud Control now. So that's getting really popular. Or with WebLogic, the very popular tool is Introscope. Right, the Introscope can be configured and it will alert with any type of these type of errors. So that's your work manager, and you basically prioritize the request and you can allocate custom threads. Now, apart from work manager, there are a couple of other things that can be tuned in WebLogic server. If you look at this one, the percentage of socket readers. Now if you see this thread pool, the thread pool has threads. Now some of these threads are used for internal purposes. For example, operating system gives the threads or requests to this process, and which means somebody from this process should be receiving those requests. Now those threads that receive the requests from the operating system are called socket readers. Means, let's say out of 10 threads, you probably have 2 or 3 threads simply taking the request, because operating system will simply give it to the process. Means, when I say process, somebody from the process, that somebody from the process is the thread. So manage server allocates these 2 threads to read it from the operating system and then put it into corresponding work managers allocated. So what we have is, in a thread pool, a percentage of thread pool is usually the socket readers. It's called socket readers, percentage of socket readers in a thread pool. Now the default value for such a percentage is 33%. So if you go into servers, server name, monitoring, threads, if you look at workload, where is it? Threads. You will see the percentage of socket readers somewhere. Workload. Where is it? Configuration. Sorry, configuration tuning. You go to configuration and tuning, you see this Java socket muxer socket readers. What we are basically doing is 30% of the thread pool we are reserving for reading the request. Now these socket readers are also called muxer threads. If you remember, when we did a thread dump analysis, some of the threads are muxer threads. The muxer threads are nothing but socket readers, and it is 33%. 33% of the thread pool is allocated for reading the incoming request. Now how do you tune it is, or when you tune it is, let's say there are a large number of requests coming into your managed servers, but the requests are very short-lived. Means the request is coming in within nanoseconds it's finishing. In that case, you would need more number of thread socket readers. So then in that case, you will usually increase from 33% to probably 40% or something. This you will increase. Or another easy indication is if you are getting too many connection refused errors, there is a problem that the socket readers are not enough. Or if the slowness because of heavy load. When you see heavy load and if there are application is slow, then you may want to increase the number of socket readers. Alright, that's one parameter. There are a lot of other parameters, but there is another parameter that you look at: stuck thread max interval and enable native IO. The enable native IO is already there. From 9.2 onwards, it's already enabled. Earlier in 8.1 when we are there, this had to be explicitly enabled. Now the native IO is basically operating system dependent. Every operating system has its own set of libraries. So WebLogic will try to use those libraries for doing IO, input output, means especially the hard disk reading and writing. Now instead of Java based classes to access internals of operating system, the WebLogic uses the operating system's own libraries, that is enabling native IO. It is by default selected. From 9.2 onwards, you don't have to really do anything. Stuck thread max interval, this is one thing that you can change if you don't want to see the stuck threads and if you know they are not stuck threads. So here this is at 600 seconds, which means we know that 600 seconds is the stuck thread, means after this time is reached, your WebLogic most likely is going to shut down. The application is obviously going to be slow and WebLogic is going to shut down the application and the managed server itself. Now if you don't want that, you can increase it to 700 or 800 seconds. Right, that's another tuning that you want to see. If your application has long running transactions, that's another tuning that you see. Alright, so these are some of the properties that can be tuned at WebLogic server level. Out of all these things, Executeq and work managers are the most important. Alright, that's your work managers tuning. After work managers tuning, there are small other tunings that you can do. You can do tuning of Gdbc, you can do tuning of Gms. These are small topics. Now the Gdbc tuning, if you see, let's see what you can tune. Now the first thing you're going to do is you're going to keep the initial capacity, max capacity same. Now from 11G onwards, the initial capacity is gone, it's not there anymore. So you have minimum capacity, maximum capacity. So if you see the Gdbc data sources, in these data sources, connection pool, earlier you used to have capacity increment is gone. Instead of capacity increment, it's minimum capacity. That's what has come in. So here, initial capacity is basically how many requests, it's how many connection objects it's creating at the beginning. Max capacity is what's the maximum number of connection objects that can be created. Minimum capacity is basically how many connection objects should be there minimum in the pool. What happens is from time to time, WebLogic tries to shrink the connection pool if there are not enough connections being used. Let's say there's a burst of requests came in, so the connection pool size has been increased to 15, but then there are no more requests. If there are no more requests, then there is no point in keeping the 15 connection objects just because we have created them once. Then it will try to shrink it. Now, to what level it should shrink it? Usually it will shrink it to the minimum capacity. Now here in this case, minimum capacity and initial capacity are same, so it will shrink it to the same value, or else it will shrink it to the number that's currently in use. Let's say 10 requests connection objects are in use. If 10 connection objects are in use, then it will shrink it to the 10. Alright, just give me one moment, guys. Okay, so the minimum capacity and maximum capacity, basically not what we usually do is, now as a performance tuning recommendation, what we are doing, initial capacity, max capacity, you are setting it to same, which means WebLogic is going to create all the required connection, means the max capacity at the beginning itself, because you said max is nothing but initial, or initial is nothing but max, let's say, put it that way. Initial is the max value, so anything that it's going to require ever is going to be created at the beginning itself. And again, obviously WebLogic tries to optimize the overall connection objects availability based on the number of requests also. Alright, so that's your first recommendation of JDBC. Apart from that first recommendation, you can enable or disable test connections on reserve for optimal performance. Basically what it does is, if your application wants the connection to be tested before it's given to it, means a guaranteed working connection. Normally what happens is, the connection pool does not test before giving it to the application. It simply does a periodic testing. If you go into advanced properties, it tests every 120 seconds, which means if it was successful 120 seconds, at one point, for the next 119 seconds there is no other test. If the request arrived within 119 seconds after the test, the assumption is it was tested 120 seconds before, it was working. But anything can happen in the next 120 seconds. So when that happens, your WebLogic basically gives a connection object a non-working connection object, but it's unintentional. Now assume that your application cannot handle such a failure. Application says that I definitely need a working connection object. So what we do is, you basically test the connections on reserve, means before it's given to the application will try to test it. Now obviously such a setup is going to reduce the performance. You don't want to test every connection object before it's given to the application. If there are 1000 requests, you will do 1000 tests, and each test is basically an SQL query to the database. So you don't want to send 1000 requests just for testing to the database. So if there are heavy loads and if you enable this thing, it's going to reduce the performance. So the recommendation is not to enable it. You don't want to test the connections, alright, before they are given to the client. Instead, you want to do a periodic testing. So you want to disable it. It's already disabled. Alright, that's the default way it is. So you're going to disable, you're going to make sure the disabling of test connection reserves is on. The next thing is statement cache. Again, here itself. If you see here, statement cache type and statement cache size. What happens normally is every time you send a request to a database, let's say there is a SQL query like this, insert into table employee values. Let's say you give two values, name and number. Employee name, let's say name, employee name something, and number, let's say 100 or 199. Now when this query gets executed, it has three steps. One is parsing. Parse means syntax check. Then compile it. Compiling is basically converting into machine code. Then executing. Execute. These three steps. Now let's say there is an insert query that came in and we inserted it using these three steps. Let's say there is another insert query with the exact same syntax but just a different value. Instead of name, you got name 1. Instead of 199, you got 200. Now it's exactly same. We know that. Obviously, the parsing means the syntax check is unnecessary. We already done it for exact same thing. Compiling is also not necessary. The only thing you need to do for this query is to execute it with a different values. Earlier it was 199 to now it's 200 with name 1. So what we do is we store the prepared statement or callable statement, it is called the callable statement of this query in a buffer. If we get the same request again, we use it from the buffer instead of going through all these three phases, which means we are skipping these two stages. Parsing and compiling is skipped. Execution is only executed for the second one. That way, by skipping these two steps, you can improve the performance. And this will work only if there are large number of similar requests are coming. See this thing. The requests have to be same. Otherwise, there is no point in storing a previous compiled statement. Because if we know that it's not going to be again, so there is no point in storing. So if application has large number of similar requests, alright, then you want to store the old compiled statement and use the same statement for the next request. Now that store is where you store such a prepared statement, which is called a statement cache, which is here. Now the statement cache size can be increased so that you can store more number of callable statements. Alright, so if you store more number of callable statements, probably you will skip more number of parsing. So that way it can increase a little bit of, especially Gdbc based, and that works only if you have a large number of similar requests. That's your Gdbc. So Gdbc tuning has three parameters. One is set your initial capacity, max capacity to same, and then enable your statement cache, and finally, which is already done, disable your test connections on reserve. And then the final one is the Gms tuning. That's the final part of tuning. Now the Gms tuning basically looks at setting up proper sizes for messaging and the overall queue. For example, you have a queue. Now you are using the default size of the queue as the queue size. If you don't want the default size of the queue, or you want to have a bigger queue or a smaller queue, you would actually tune the size of the queue. The same way, each message in the queue also needs to be tuned. So if you go to the console, let's say here, under services, messaging service, to see GMS module, let's go to the queue. Alright. Now you got a lot of things here. Out of these things you got thresholds. So you have thresholds and quotas, maximum message size, all these things. Now the maximum message size, let's say you don't want this, you want to increase the size. The messages threshold, this is the upper threshold, the total number of destination messages in the destination. Right, now these parameters can be tuned. This is very rare that you need to tune this one, but still it can be tuned. So the queue size, overall queue size, and the individual message size in the queue. The second thing that you can do is you need to enable paging, especially if you have a persistent store. What happens is, let's say there is a YouTube message. The YouTube message, if you have enabled what we call a persistent store, the YouTube message can be stored in the persistent store, and only the header message of the YouTube message can be put into the actual queue. It's like, let's say you're using the Outlook in your office. When you open Outlook or when you see something in the Outlook, it is not actually the entire message that is downloaded. Let's say there is an attachment in one of the mails. The attachment is not downloaded. Or let's even in your Gmail, let's say you open a Gmail, there is an attachment. You can set up an option that don't download the attachments when I'm opening the mail. Only when you click on the attachment, that's when it goes to the server and brings up. It works it works exactly the same way in Outlook, especially. Outlook only shows you the subject message of mails. It does not have the entire message itself in it when you're looking at the inbox. When you click on any of the messages, that's when it goes to the server and brings up that message. The idea is you may not want to read all the messages. So there is no point in downloading everything even before you are reading them. So when you click on anything, that's when the download happens. Now that's called paging in a way in GMS. So if there is a message in a queue, and if you have a persistent store, the message is actually in the queue only when the receiver is receiving it. Otherwise, there is only a header of the message in the queue. Now that way, what happens is your queue size will be limited. By limiting the queue size, you will obviously have less amount of memory being consumed out of JVM. So you may not, you won't get into out of memory issues. So paging enabling of a queue usually helps in improving the performance, and also you are reducing the amount of IO that you are doing, reading and writing from the disk. Alright, those are the two things that you will tune in GMS, and that's your entire performance tune. JVM, WebLogic Server, Gdbc, and GMS. Alright, that's all guys. With that, we have finished all WebLogic related things successfully. So if you have any questions, you can ask me. I think I promised you a couple of things like SSL for Apache. It's going to come. And is there anything else that I said I'll give it to you? Apache SSL is one thing I remember. I believe Ant video was another thing. Yes, the Ant script. Okay, that's the second thing. Okay, these two I already remember. There's nothing else, right? Upload the video. Okay, I will do that. Sure. Upload the video on count basis. Okay, so I'll re-encrypt everything and give it to you. Anything else? Interview questions? Did I not send interview questions? Okay. Oh. Sample resumes, okay. Sample resumes, I thought I'll send it. Yeah, passport thing will take. Yeah, interview questions and sample resumes also I'll send it. Let me just write it down. SSL for WebLogic and script. Interview questions. Sample resumes. Then count-based videos.
Anil, this is Srinivas. Hello.
What? Any questions, guys?
Anil, this is Srinivas. Hello. Hello.
If that's all, I would like to request you one final thing. I want you to put your feedback on this encodeit.in thing. Please put anything that you want to put. So in encodeit we have a feedback here. So go to feedback and please put your feedback here. I just given some guidelines here. Alright, these are the 4 guidelines about which try to put your feedback instead of a random thing. I really appreciate you putting your feedback over here. It will help me.
Hello.
You can't hear me? I can't hear you. No, Srinivas, I can't hear you.
Just a second.
Thing looks like there's a problem. You can type it if you want. So please put your feedback. I really appreciate it. It's on our website at feedback tab. Right? Just these are 3 or 4 points for where you would consider putting your feedback. And any other questions, as usual, you're more than welcome to send me an email, or you can call me. I'll be usually available in the evening times. Morning times I may not be able to pick up your call, so I'll be either in class or office. So evening after 3 o'clock India time I'll be free. I'll be able to pick up your call and answer it. Try to call me if it's an emergency, otherwise email is the best way to reach me. I'll try to usually respond to emails within a day. There is nothing like patching in a server. It's a general patching. So the patching we will probably I'll again send another document for patching also.
Anil, can you hear me?
So patching for a cluster, there's nothing like patching for a cluster. Patching is just a patch. The patch may be related to cluster. But we will I'll send out a document or something about patch. Anything else? Yeah, whether the servers are in a cluster or not cluster, it doesn't matter. Patch is a patch. Patches are usually at your WebLogic level. So when you update a patch, it basically updates certain jar files. So when you say a cluster patch, it means it updates jar files related to a cluster. Whether servers are in a cluster or not in a cluster, patch doesn't distinguish. All patches, they get applied the same way. So there is not one process for clustered servers, a different process for non-clustered servers. There is no such thing. You can apply it online, but you don't depend on Oracle's website to do that, right? You download them, you keep it with you, you have a production maintenance window, you apply it. So patches are always applied offline. That's the best way to do it. Online also can be applied, means live patch you can apply, but that's very rare. You're depending on Oracle website, and nowadays Oracle website is pretty unreliable. Srinivas, I think it looks like you're talking, but I can't hear anything at all.
Okay. Now, can you hear now?
I can see here on the GoToMeeting that you're talking, but I'm not sure if you're trying to say something. I can't hear anything at all. Any other questions, guys? Srinivas, if you have any questions, please put it on the chat. Yeah, you can send me an email. That's always you can do anytime. That's cool. If you have no other questions, guys, thank you very much. Thanks for your really patience.